Okay, welcome to this lesson on factoring simple trinomials. And this is the note. If you haven't opened it, you can maybe go grab your note and open it up. But before I actually begin, I'm going to actually go backwards and go back to multiplying two binomials. So I'm just going to do a simple example and then we'll talk about it a little bit before we move on and do four additional examples. Okay, so just getting myself a piece of blank page and I'm going to make one up here, just a really simple uh, example to work with. I got to get my pen activated here, sorry. So here we go. I'm just going to say x plus 3 times, say, x plus 5. That's my example. I'm going to multiply those two together. That's one binomial multiplied by another binomial. And if you recall correctly, we used something called FOIL, or in other terms, sometimes referred to as the bird, to multiply this out. And so what happened was we said x would multiply first by x, and that gave us x squared. And then x would multiply by 5, and that gave us plus 5x. And then we'd go 3 multiplied by x, and that gave us plus 3x. And then finally, 3 times 5, which gave us 15. And if you wanted to go back through that, that was the first two, the outside two, the inside two, and then the last two, which stands for F, uh, first two, outside two, O, inside two, I, and then 3 times 5 is the last two, and that spells out FOIL. Other people somehow see a bird in here. I've never really seen it, but whatever way, it's good for you. Now, when you do multiply two like binomials like this, you'll notice that you have two like terms, and that is the 5x and the 3x. The x squared is by itself, and the 15 is by itself. They can't be added or collected, as you would say. And so you end up with an equation that says x squared plus 8x plus 15. And the only term that's really changed or become different is the 8x after this first step, because it combined these two middle terms, the 5 and the 3x. And so we have something different. And when we examine this closely, we'll notice that every single time the first term becomes x squared, simply x times x. And every time 3 times 5, these two terms give us this value 15. In other words, when we're going to work backwards, that's what factoring is. Factoring is going this direction. We're going to make a multiplication question of two binomials. And we're going to say that this term here, this 15, always has factors, and those two numbers, 3 and 5, must multiply to give us this 15. Now, we also know that those factors, 3 and 5, usually have to combine to give us the middle term, which is 8. In this case, they have to add to give us the 8. And we're going to use this information to help us factor the questions above. So I'm going to move to a couple of examples, and we'll use some ones that we have positive and negative signs. So we're going to start with something with a positive signs, but we will eventually get to negative signs as well. So let's start with the first example, which is x squared plus 8x plus 12, and we want to make it into a multiplication question. So I always said the first thing you need to do is recognize that we can make this into a multiplication question by putting our brackets down. And I think I always tell kids, just by doing that part, just by doing that step, you're telling me you understand something about factoring a trinomial. That means you recognize this is a trinomial, 3 terms that can be factored into two binomials. Okay, and the factors of x squared are only x times x. That's the only option you have. You don't have any other option there. So we know that the first two terms have to be x and x, because when they multiply back together, they will give us this x squared. All right. Now we can look at the second term, which is a little more tricky, and think of all the possible factors, all the different ways that it can multiply together. And so for one, it can be 1 times 12. That's one way. Another way it could multiply is 2 times 6. And another way that 12 can multiply is 3 times 4. Now, you may not remember all of the factors of a particular number, but that's why we have a factor sheet that lists them all. And I always let kids use that factor sheet on a test so you can look them up. And that way you're not sitting there struggling to try to figure out what all the factors of a number are. So these are the different ways that they combine. Now we have to figure out which one of these is going to work to put the numbers in here such that we can get 8. And because this is a plus sign, because we know it's plus, we know that this number has to have two numbers that multiply it to give us a plus sign. Would either have to be two negatives or two positives. We couldn't get it if one was a positive, one was a negative. So therefore, which one of these add to give me 8? Well, 1 plus 12 is 13. That's not 8. 2 times 6, or 2 plus 6, is 8. Ah, that one seems to work for me. So I circle it. And I usually put my larger number first. It's just one of my policies, and my smaller number second. And how do I get to 8? I have to add. So plus and a plus. It's not subtraction. And I'm done. I have finished the question. And if you wanted to check it, you can go x times x is x squared. X times 2 is 2x. 6 times x is 6x. And 6 times 2 is 12. 2x plus 6x will in fact give me 8x, so I have the correct answer. And I'm just doing a quick mental check. I mean, that's a rather quick way to go about it. You could go through the process just like we did in the previous question down below and walk through it. Now here's a question that's very similar but different in that I'm going to scroll down in that the term in the middle is now negative 8x. Okay, and it works the same way. I'm going to start by writing my brackets in because I recognize that this is a trinomial. 3 terms, x squared minus 8x and plus 12. And then I know that x squared can only be factored into x times x, so I'm going to write x and x right off the bat. Now I'm going to write the factors of 12 again. So 1 times 12, 2 times 6, and 3 times 4. This time I need to find a way such that when I add these two or collect them together, I will get minus 8. But when I multiply them, I'm going to get 12. Well, the only way that's going to happen is if this one's minus and this one's minus. So it's the same pair as above, but this time I need negative 2 and negative 6. So I usually write minus 6 minus 2, and away I go. I'm set. I now have factored this particular question. Basically, factoring it makes it into a multiplication question. 2 minus x, or sorry, x minus 6 is multiplied by x minus 2. Those are two binomials, and we've turned it into a multiplication question. Okay, so now we'll move on and do another one, just a little different. I thought I'd change up the numbers slightly for you and show you this one. And this time, oh wow, it's interesting. I've got a negative and a negative here. But again, I have a trinomial. So once again, I can start by putting in my brackets. Bracket, bracket, bracket. And x are the only options to factor x squared. That's the only options I have. Now I want to write down my factors of 21. Well, I have 1 times 21, and I have 3 times 7. Now, that's all the factors I have of 21. 1 times 21 and 3 times 7. There's no other options available. 2 doesn't multiply by something to give me 21, not whole numbers anyway. So I'm left with these two options. But I see that my 21 is negative. So that means one of these has to be positive and one term has to be negative. So one would have to be either negative and 21 positive or the other way around. But what I want to do is I want to find a pair that will give me a difference or some way to make one positive, one negative that would be minus 4. Wow. Well, the difference between two numbers has to be 4, and that's clearly the 3 and the 7. The difference between 1 and 21 is 20. And I always say to kids, well, what's the difference mean? What do you mean by that? And I said, well, imagine if somebody had $21 and another person had $1. What was the difference in the amount of money they each had? Well, the difference would be 20 bucks. Well, that difference is not 4. But if one person had $7 and another person had $3, the difference is in fact going to be 4. Now, I always then write these in with the bigger number first. 3 and 7. And then I basically say to myself, well, how can I make 7 and 3 be minus 4? Well, the only way that can happen is if I go minus 7 plus 3. That'll be minus 4. And the way I write it is if I put my bigger number first, I always give it the sign that's in front of the middle term, and that sort of helps me recognize these two must have the same sign. This one would have the other sign. And away we go, right? That happens, that rule of sign rule always applies when one's going to be positive, one's going to be negative. All right, let's go to one more example, and that'll wrap it up for these simple trinomials factoring. Once again, three terms, 1, 2, 3 terms, x squared plus 8x and minus 9 are the three terms. So therefore, brackets can be set up right away. And I can stick my x's in. And I've told kids, like, this is already telling me you kind of have an idea of what you're doing. Just writing that in is a good sign, okay? Now, I'm going to write my factors of 9, okay? 1 times 9 and 3 times 3. And again, if you don't remember these factors, you just go to your sheet and look them up, okay? The sheet is available online and it's printed off. You can look at it any time, okay? Now, I'm looking at these and I'm saying, well, one of them has to be negative and one positive for me to get minus 9 and then plus 8? Wow. Well, the only way that's going to happen with any pairing here, if I was positive and negative here, that would actually end up being 0. So that one's not going to work. But the 9 and 1, I think I can get that to 8. I can say this is plus 9 minus 1. So I write my bigger number first, my smaller number here. The value of, or the sign, sorry, of the middle term goes in the first one, plus 9 minus 1. So positive 9x minus 1x is going to give me 8x, and I have completed my factoring of my trinomial. This is the lesson on factoring simple trinomials. When we get into more complex trinomials, that's generally left for the academic kids. There's some extra tricks that we can pull out of our sleeves, but that is factoring simple trinomials. Hope you enjoyed the lesson. Go ahead and work on the worksheets, and we'll see you in the next lesson.